talk lesson 26 and get these notes. Okay? We are doing yet again more derivatives. And again, so at this point we are building a repertoire, if I may, of derivatives. Okay? It's like, ongoing just adding derivative rules at this point. You know the basics of if you have a basic term, just a basic monomial term, or even a polynomial. You know how to take those derivatives, right? Where we move the power out front, subtract 1 from the power. Now, if there's a coefficient out front, you multiply that in. If you're adding and subtracting terms, you take each individual derivative. We're going to add in some special derivatives, our first set of, other rules today. And we're going to talk about the derivatives of e to the x and the derivatives of ln x, in other words, natural log of x, and sine x and cosine x. Okay, and then we also have an exponential growth problem to look at on the back. So, these are rules that memorize them. Okay, you've got to flat out know them. So, the first two rules up here, derivative of e to the x. The derivative of e to the x is e to the x. About the only time that ever happens, but the derivative of e to the x is itself. Okay, it does not change. Your what?
My text
Want to do your quiz corrections?
Yes. Yeah. I just want to look over one more time to make sure I have everything in order.
You can do that. There you go, my dear.
Thank you.
Okay, and then what's the other one there? Derivative of natural log of x.
1 over x.
Derivative of natural log of something is 1 over something. So derivative of natural log of x is 1 over x. Store those in your head. Got it? So, find dy dx given that y equals 4 natural log of x minus 6 e to the x plus 2x squared. We're just going to include all rules right off the bat. So, it says y equals, we're being asked to find dy dx. So dy dx equals. Okay, thoughts on the derivative of 4 natural log of x? One over x and then what? Not to the 4th. As in what? Not 1 over 4x. 4 over x. Okay, so I'm going to break it into pieces. This 4 is a constant, yes? So I'm going to say 4 times, because 4 is just a constant. What is the derivative of natural log of x? 1 over x. So we're essentially doing 4 times 1 over x. And 4 times 1 over x is 4 over x. Does that make sense? So cleanup form is 4 over x. If you write it in pieces to begin with, which you probably won't once we get past this initial introduction, but you can. Okay. Minus 6e to the x. Derivative of 6e to the x? 6e to the x. Because, so again, the 6 is a constant. So we just keep the constant. What's the derivative of e to the x? E to the x. And 6 times e to the x is going to be 6e to the x. Plus derivative of 2x squared. 4x. Using our old rules, bring the 2 out front. 2 times 2 is 4x, and then subtract 1. 2 minus 1 is 1. So our derivative final answer reads, I kind of wrote it in as we went, 4 over x minus 6e to the x plus 4x. The key is to remember that coefficients, you can just multiply them back in at the end. Questions on that one? Okay, ready to try another one? Oh, I forgot. This is the... Okay, so derivative, y equals 4 natural log of absolute value of x minus 6 e to the x plus 2x squared.
Same answer as the top.
She says same answer as the top one. What's the only difference in this problem?
It just says L1.
Okay, instead of natural log of x, it's natural log of absolute value. What's the absolute value mean? The absolute value guarantees us that there will only be, yep, only positive values there. Which, if you think about it, officially x has to be positive for this to work, because we can't put a negative into a log. Okay, so does that change our answer any? No. And the point is going to be whether there's absolute value around the x, like in this problem, or whether there's not in the last problem, the answer retains the same. So dy dx equals 4 over x minus 6e to the x plus 4x. So really no difference. It's just, you know, putting the physical descriptor there that, okay, it has to be the absolute value of x. So I guess the difference is on this one, you could put in a negative value, because then the absolute value is there to tell us to turn it positive. But, okay. Let's go with our two other rules here. Two other rules. Derivatives of sine and cosine. You ready? The derivative of sine x is cosine x. No, you can lay it on my desk. Okay, derivative of sine x is cosine x. So you're all done, Zephanie? Mm-hmm. Okay, good deal. Thank you.
Welcome.
The derivative of cosine x is, notice, negative sine x. So when you're going from sine to cosine, it's a positive. But cosine to sine is a negative. Figure out a way to memorize those. Ready for example 3 here? Find the derivative of y equals 3 sine x minus cosine x plus 2e to the x. So, dy dx, always label your derivative when you get started. So whether it be y prime, dy dx.
Why or do we just put d over dx since the example says d over dx?
Okay, so when you use d over dx, that means the derivative of that term right there. So you put it directly in front of a term you're taking the derivative of. When you're trying to find the derivative of y, then there needs to be a dy in relation to dx. Okay? Okay, so 3 sine x. Officially, the 3 stays 3. And what's the derivative of sine x? Cosine x. Minus, what's the derivative of cosine x? Negative sine x. So I will clean that up to be plus sine x in my next term. Plus 2 times what's the derivative of e to the x? Stays the same, e to the x. So if I clean this up, it becomes 3 cosine x plus sine x plus 2e to the x. Are we okay with that one? Example 4. Derivative of y equals negative 3 cosine x plus 3 natural log x minus 2 sine x. So again, dy dx equals. Okay, the negative 3, I'm going to keep negative 3. What's the derivative of cosine x? Negative sine x. And I'll clean that up in my next step. Now keep in mind, as you get better with these, you have to write this out in 2 steps. No, this is me just trying to break it down for you because this is day 1. Plus 3 times the derivative of natural log x is 1 over x. And Mallory went ahead and said, okay, that's going to be 3 over x. I agree. Minus 2 times the derivative of sine x, cosine x. So, if I rewrite this a little nicer, it becomes positive 3 sine x plus 3 over x minus 2 cosine x. Cannot stress enough. Flat out memorize those rules. That's what a lot of derivatives come down to, memorizing some basic rules. Okay? You got what you need in the way of derivatives today? Okay. Let's go back and look at an exponential growth and decay problem, which we will build on this throughout calculus. These do keep coming up in your calculus homeworks.
I've always liked these. Decay in the cave.
Exponential growth in what?
The cave. I say, let's look at the exponential growth in the cave.
Exponential growth in the cave. Okay.
Flip the page. I understood.
Yeah. Okay, well, yeah. Let's see. Bacteria could grow in a cave.
Bacteria can grow anywhere.
I thought there was just like a black population.
Okay.
Or something anywhere.
Okay. Anyways. Okay, so exponential growth and decay. Not decay, decay. Okay. It doesn't work. Okay. So, general form of an exponential function is given here. So, a of t, so that's just the amount at a time t, equals a naught or a sub o, I don't know how you guys have heard it, times e to the kt, where t, as always, is time. A naught or a sub o is the original amount.
In physics, we call that
A initial? Okay. So, I'm surprised. I wonder.
You called it A naught before.
we call it A naught in first day. But then
Okay, because I would have said A naught, like maybe that's more chemistry or something, but okay. A of t is just, the amount at time t, so kind of like overall total amount. And K is the growth constant. Okay, so K is going to vary from problem to problem, and that's usually you're going to start off by having to find K based on some other information. So, as it says right here, we usually have to solve for K before we can solve for what they are asking for. Okay, you ready? The number of bacteria present at noon was 400. 9 hours later, the bacteria numbered 800. Assuming exponential growth, find an equation that describes the number of bacteria as a function of time t, where t is measured in hours. Then find the number of bacteria present at noon the next day. So, that last sentence there, find the number of bacteria present at noon the next day, forget it for right now. Okay? We've got to worry about first finding an equation. Okay? So, what kind of information can you tell me? Okay, the number of bacteria present at noon was 400. And 400 is going to be our A naught, A sub 0, A initial, whatever you want to call it, right? 9 hours later, so 9 hours later is a time, okay? Because this is all we're working to find, we're going to have to work to find K here. So we're using all the givens to find K. So A naught started as 400, where my amount started as 400. 9 hours later, the bacteria numbered 800. So this 800, if my hours are 9, this is going to go in for A of t, because this is going to be your amount after t hours. If we use the equation given up there, A of t equals A naught e to the kt. Fill in what you can, which if we've done this correctly, we can fill in everything but k, because we're finding k. So A of t is the amount is 800. A naught, we said 400. E to the k that I don't know, and t. Okay. Your job on these, I don't know, do you guys know your first step? Divide by 400, because we want to get that e to whatever power by itself. So if we divide by 400 to get e to the power by itself, we divide both sides by 400. 800 divided by 400 is 2 equals e to the 9k. Yeah, the whole point of getting e to some power by itself is that now, because we need that k out of the exponent to begin to solve for this. So we're going to take the natural log of both sides. So the natural log of 2 is natural log of 2. Natural log of e to the 9k. I wrote that piece in there, but what do you know about the natural log of e to the 9k? Okay. 9k could go out front, but even better is it's just going to be 9k because natural log is what base? Base e. So this is a log base e of e to some power. So what's the shortcut? Is that this just equals 9k. So you have 9k is equal to natural log of 2. So what does that make k? Okay, divide by 9. And k is the natural log of 2 divided by 9. I am fine with that form. Natural log of 2 divided by 9. I'm also fine, and I'm going to put this because you see it sometimes. That 9 is in the denominator, right? If you pull that 9 out front, this is also 1/9 natural log of 2, if you want to think like that. I don't know that I have a preference necessarily. I just have both written in my notes. They're both equivalent. I just wanted you to see them. Okay, so can you write an equation that now has k filled in? Because it said you write, my goal is to find an equation that describes the number of bacteria as a function of time t. So, I need an equation for A of t is what that's saying. A of t is going to be what? Well, A naught, we already knew that, right? That is 400 e to the kt. Do we know k now? Yeah. I have written natural log of 2 over 9 times t. You could also write it 1/9 natural log of 2 times t. But that is my equation. It is an equation that describes bacteria as a function of time t. Thus, A of t. Okay. I said to forget the last equation for a moment, or last sentence, excuse me. It said, then find the number of bacteria present at noon the next day.
It'd be 9 p.m. because it started at noon and it goes to 9 p.m. Then you have to go to 12 the next day, right?
Start with 400 at noon.
Okay. And this is, what was our initial value?
24 hours after
Right.
that.
Our initial value here was 400, and that was at noon. Now we're doing noon the next day, which is a total of 24 hours. And my T has all been in terms of hours, right?
Yeah.
Now, we couldn't switch back and forth hours one time, minutes the next. We have to be consistent. So, yeah, we are finding A of 24. So, 400 e to the natural log of 2 divided by 9 times 24. How talented are you with your calculator? I have written down my notes 2539.841683. That's what I have written down that I had got from my calculator. Okay. So your calculator just rounded at a different spot there if you have 8417. Whole bacteria. Approximately how many bacteria is this? 2,540 bacteria. And notice my squiggly equal sign indicating approximate. Okay.